Hey, I'm Jacqueline from Major League Hacking, and this video is presented by Capital One. Now, in this video, we'll be teaching you a little bit about Python and giving you a very, very brief taste of game development. Before we dive into Python though, I want you to think, what makes games interesting? Why are they fun? And can you think of a really fun game? I'll give you a second. Well, I can almost definitely guess that you didn't say that rules are what make games fun. But believe it or not, they are. Because without rules, you or the computer wouldn't know what you were doing. For example, in a game such as tic-tac-toe, if there's no rules, you could start your turn and you could do literally anything. For example, you could put an X in a box, or you could put an O, or a poop emoji, or you could turn the board into a birthday cake. Wait, that doesn't sound right. This is why rules matter. Rules tell us what we can do and what we can't do in a game. And in tic-tac-toe, an example of a rule is that you can only put X and O symbols in unoccupied boxes. And think for a second, your friend would tell you to stop if you tried turning the board into a birthday cake, or if you erased an O and put an X. And another really important rule if you're playing tic-tac-toe in real life is you and your opponent decide when the game is over because someone's won. That's also a rule. But computers are really good at rules. Computers do the same thing as you and your friend. They say, hey, you've won. But unlike your friend, they'll force you to play by the rules too. Now, one of the really fundamental concepts of how we enforce rules in programming is state. State is what is happening on our board right now. For example, in tic-tac-toe, the locations of the X's and the O's on our board could be stored in state. And state is what makes video games work. The game looks at the current game's state and then applies rules based on it to decide what can happen next. Now, in tic-tac-toe, like many games, the same rules apply every turn. And the computer looks at states to decide whether you're allowed to make a move, which is a rule. So, that state, you know about it. Let's also talk about another concept you need to understand for this video. Let's talk about the game loop. The game loop is the process of applying the same rules every time. The game loop looks at the state to determine what it should do next. So let's talk tic-tac-toe again. For example, a computer would see a tic-tac-toe board and it would say, you can put an X in any of these spaces. Then, when you've gone and put your X in one of those spaces, it would play its move using the knowledge of the rules. So it would say, I could put an O here and try and win. And this process repeats itself over and over and over again. That's why it's a loop. Eventually, one side will win the game based on its rules, or there'll be a draw. And the computer will tell you when this happened. That's because it knows that's a rule. Okay, that's enough about tic-tac-toe. Hopefully you understand these two very important concepts now, state and the game loop. We're going to write some code. So head over to this link, mlhlocal.host/rock, paper, scissors to get started. Okay, now you're here, I want you to go and click the remix your own button. And in just a couple of seconds, Glitch is going to go and spin up an environment where we can go and write some code. We're going to be learning Python by doing. Now, this is your code. You can edit it, you can reuse it, you can break it, and you really should make it your own. Go wild. And after this video is up, feel free to change it however you like. Oh, and before we jump in, one final heads up. Learning to code can be difficult. We're going to go through this project together now, but if you get stuck, don't be afraid to Google or, have a look at other resources. And making mistakes is okay. Everyone makes mistakes, and mistakes are how we learn. So here's our project in action. It's a super simple rock, paper, scissors game where you, the player, play against the computer. We'll jump into how this actually works in just a bit. Now, this project is built using Python code, and you can see the code that runs it by opening the game.py file on the sidebar. There's quite a lot of code here, but don't let it overwhelm you. We're going to walk through what it all means in just a second. But before I do, let's think for a second, what is a python? Well, a python is a type of non-venomous snake. They're often found in Africa, Asia, and Australia. But wait, no. What is Python? Well, Python is a programming language. It's used for all sorts of things, including web development, data science, and creating artificial intelligence. Now, remember I told you about the game loop? If we scroll down, I think we can find one just a bit down here, hiding right at the bottom. This code is the game loop that we talked about earlier. It keeps running when we don't have a winner. And in our game, a winner is declared after 5 rounds. Now, the code inside our loop will keep running until the loop knows to stop. and we know the code is inside because it is indented. You see it moves in slightly? Our loop keeps going until a conditional is no longer equal to true. Now, conditionals are just statements that can either be true or false. And here's our conditional. It says, while not winner. While there is not a winner, keep running this loop. Okay, that was quite a lot, so let's recap real quick. We're programming a game using Python. Our game runs in a loop, which runs until a conditional is no longer equal true. Our conditional is there not a winner? But how does the game decide if there's a winner? Well, our game also uses rules. One of the rules of rock, paper, scissors is that each player makes their move and chooses rock, paper, or scissors. And our code tells the game to follow those rules. But how does our computer know to follow these rules? Well, take a look on line 85 and 86. We have something which says ask move and make move. It's our computer asking us to make a move and the computer making its own move. These are called functions. Functions are blocks of code which tell our code to do something. Now, we've also got player move and computer move, and player move is set to equal whatever ask move is equal to, and computer move is set to equal whatever make move is equal to. Both player move and computer move are variables. Variables let us store a piece of data, and then we can go and use that piece of data inside our game. You should know that there is multiple different types of variables that store different types of data. The main two types you need to know about today are strings and integers. Strings store text, such as words and sentences and paragraphs. You know data is a string because it is surrounded by quotes. Here's an example. Another type is integers. Integers store whole numbers. So heads up, they can't store decimals. You do not need to put integers in quotes. Here's an example of what an integer looks like. Phew, mind blown. That was a lot to take in. But you now know the fundamentals of programming. Yeah, seriously. The most important thing for you to remember for the rest of this video is that the computer is looking at all the rules you write and deciding what to do based off them. Let's take a look at one of those rules now. We're going to take a look at how the ask move function works. You should follow along in your own code while I do this. So this code is what is run when we call the ask move function. If you scroll up in your file, you should be able to find it. Now, this code asks our user to type in the move that they want to use. By using an input function, we're telling the computer print out whatever's in our parentheses, and then we're going to wait for the user to type in something to the console. We'll get to what that is in just a second. Or to input something and save it to the variable move. If the move they enter isn't valid, we print an error to our console. Oh, and just a heads up, if I say print, it just means we show a message to the user. If the move is valid, then our code makes the user use that move. Now, remember how our game loop uses a conditional to keep the game running until a winner is decided? Well, our rule here also uses a conditional. So let's talk about if statements. And yeah, we're throwing in tons of different concepts here really quick, but feel free to pause the video or slow down or go back if you need to go and refresh your memory. Sometimes we only want to run code if a conditional evaluates to true. And here's an example of us doing this. We use an if statement to do something. So we print an error if a move is invalid. If you get confused, just remember, if statements contain code that only runs if a condition is true. They're like logic in your program. Now, remember how we talked about strings and integers and how they're the two main types of variable? Well, I lied. There is one more you need to know, but I promise this is the last one. And you probably already know them. They're called booleans. Booleans are a type of variable that contain the value true or false. So in our example, move not invalid moves would be our boolean. So now let's go back to our if statement. Our if statement checks if the move we enter is contained within our list of valid moves. If it's not, then our code will print out an error into our console. It'll tell us an error. Otherwise, it will cause the player to use that move. See, this is all just rules. Our if statements run code if a boolean evaluates a true. That is a rule. Seriously, building a game or any type of program is just like putting multiple rules together. We'll jump into programming in just a second, but there's one more thing I want to tell you about first. Remember how we can make rules? Well, our computer can make rules too, because computer move is equal to make move. Let's take a look at how make move works. So this is how our computer decides what move to make. Might look a bit confusing, but don't worry, let me talk you through it. First up, in this code, we use the length of the game's state to decide which move the computer should play. Now, state just contains a list of our moves, and this means our computer will cycle through different moves: rock, then paper, then scissors. Now, our moves are stored in a list. Lists allow us to store multiple variables at once. You can tell a variable contains a list by the square brackets surrounding it. So, what this code does is it cycles through our moves, it says a catchphrase, and then it uses that move. Okay, that's enough talking. Let's go and play some rock, paper, scissors. To run this game, in the bottom left-hand corner of Glitch, you should see a Tools button. Give it a click, and once you've done that, click Terminal. Now, a terminal is just a place you can type commands to a computer to make it do something, and it will give you some data back. So you can say, hey, do this thing, and the computer will do the thing. To run this game, we want to use this command, -3 and then a space game.py, which basically just means run this file using Python. So let me show you the game. I can say rock, I can say rock, I can say paper, and I can say scissors, because I know how this game works. I won because I already know all the rules. Now, you may see the catchphrase Bazinga being shouted by the computer every single time it uses a move. Now, I'm part of Gen Z, and I don't think Bazinga is a very good catchphrase. So let's have our first foray into programming by changing this phrase to something less cringy. Let's scroll up, and let's see if I can find where this is. See if you can beat me. Well, I think I can see it. If we wanted to change a catchphrase that our computer says, which line would we change? Well, I think there's a pretty obvious one here. Let's go and change it to my favorite word, eat. Now remember, this is a string. It's really important you remember the quotes around whichever catchphrase you put in, because otherwise, well, it won't know it's a string and it won't work. But once you've said it, see if you can find out if your code still works. Go back down here, and as a little tip, press up to rerun the command you used last. Let's try running this code again, and let's see if my new catchphrase is here. So let's try using a move. And hey, I lost, but it shouted yeet, so I'm going to call that a success. Now, as a heads up, if you got an error rather than your game running, you probably just made a typo. Typos are really, really common when programming, and the most likely one you made was you just missed out the quotes around your word. So feel free to undo and try again. There's nothing wrong with that. So I think we've done a pretty good job here, but wait, what if we made our game have multiple catchphrases? Well, is that even possible? Our catchphrase is stored as a variable. Variables just store a single value. We want to store multiple values. We can't do that, I don't think. Can you think of something we could use here that would work better? Well, yeah, obviously we have lists. A list would be a really good fit since they can store multiple values. So we can store multiple catchphrases. Let's try changing this code to be a list. So I'm going to go and get rid of what's already here, and I'm going to go and put some of these square brackets. Inside of them, I'm going to go and put a selection of my best catchphrases. So I'm going to go and say yeet, because that's definitely still a catchphrase. I'm going to do a comma, and then in quotes, I'm going to do another catchphrase. This time, I'm going to be like, woo. And I think one final catchphrase I'm going to go and put is, what's the best catchphrase I can do? Boing. Don't think anyone really says that, but I need a word, and my brain's gone blank. So hey, it's a catchphrase now. Make sure you put at least 3 moves. This is awesome. Our list now does contain multiple values. But there's one more bit of code we need to change. Because, well, we have multiple values, but we need to tell our computer which value to print. Now, I think we should cycle through these 3 catchphrases in the same way we cycle through moves. We can go and use number. Now, we're able to access a specific value in a list. To do that, we go and use some square brackets around its name. So, where we're saying print catchphrase, let's go and say we want to print catchphrase number. Now, because of our code on line 46, the first time this runs, it will go and print yeet, then woo, and then boing. This is the exact same way our computer decides which moves to play. Okay, you've just done some real programming, but hey, heads up, computers are really dumb. Yeah, seriously, they will do exactly what you tell them to do, but they can't understand anything if you make a typo. Now, in programming, a lot about what you do is making things match up. And there's a lot of brackets around the code we just wrote, so make sure things match up. Any opening brackets need to have closing brackets too. If you have a string, they both need to have the same types of quotes on either end. And also, and this one's really important, make sure your indentation is correct. You can indent code by pressing tab. It just means to go in. Now, Python, unlike some programming languages, really cares about indentation. If it's wrong, your code won't work. We'll talk a little bit more about indentation later in this video. So go back to your console, try running the command python3 game.py again, and you should hopefully see all your amazing catchphrases in action. Pretty cool, right? You just wrote the code that makes it do that. Seriously, you're a programmer now. Now, using your newfound programming skills, let's make our code less boring. Right now, our code just cycles through the same moves over and over again. It's boring, it's predictable, and you can really easily beat the computer. So let's use our big brain energy. Let's make our code a bit smarter. Rather than just looping through all the different moves, let's make it so our code beats the opponent's last move. That way, if they try to be really sneaky and repeat the same move, the computer will win. Cool, onto the code. Let's see if we can develop this. So we're still in our make move function, the code that makes the computer make a move. Well, first up, let's go and get rid of what currently decides what our move is. But we don't want to delete it. We might want to go back to that in the future. So if you click at the start of the line and you put a hash, this is going to turn the code into a comment. A comment is a bit of code that doesn't actually do anything. Nothing after a hash will run. Just lets us give notes to ourselves, or it lets us have code that we just want to keep there in case we want to use it again. So feel free to comment out code as you see necessary. Okay, next up, let's go and work out what our last move was. I think the best way to do this is to create a variable called last move. So let's try doing that now. Last underscore move. Now, last move, I want to be the last thing in our state. Because remember, our state stores a list of the moves that we've made. Well, actually Python makes this really easy. We can say this is equal to state. Now remember, state is a list. And it's going to be state minus 1. This means the last one, the first one at the end of the list. The magic that makes this work is the exact same thing as what makes our catchphrase work, just a little bit different. Finally, I think we should go and add an if statement. This if statement will decide what move to make based on the move used before. So let's have a go at writing an if statement. We're going to say if last underscore move, so the last move that was used, was equal. Now, in programming, you use two equals to mean equal. It's a little bit different to math. If it's equal to rock, so if the last move was rock, well, in rock, paper, scissors, paper beats rock. So we want to go and use paper. So we're going to set our move to equal paper. Now in if statements, we can go and say, hey, actually, if it's this, do this, but otherwise, else if, or in Python, elif, I want to go and say my last move was equal to paper. So if my last move was paper instead, then, well, before I decide, let me just really quickly address something. You might notice my cursor going back and forth like this. This is me indenting and unindenting. Any code inside the if statement needs to be indented, so Python knows to only run that code if that conditional evaluates to true or is equal to true. So we only set move to equal paper if the last move was rock. And we only set the last move to, well, scissors. Move equals scissors. If the last move was paper. Now, when you press enter, glitch will automatically indent you, but we want to write an else now, because if it's not rock or paper, it's going to be scissors. So we need to hold down shift and press tab. That's going to unindent our code. It's going to move it back to being where it was before. And so we can say else, our move should, if it's not rock or paper, well, our move should be what beats scissors, which is rock. And, well, I made a typo there. It's really easy to make typos on programming. I need to say it's equals to, remember? Hey, stop for a second. It's Jacqueline from the future here. I made a mistake and I made a typo. Super easy to do when programming. I accidentally said move is equals to rock. You don't need two equal signs there. So if you see that anywhere else in this video, just ignore it. If you've got one equal sign, you're good to go. Cool, back to the video. If you make a typo, it's okay, but I think I just made another one. Can you spot it? Pause the video and take a look if you can't already. Well, I indented my code too much, didn't I? Look, this is here, but I indented twice. If I indent it twice, then my code won't work because it's Python. So to fix that, let's just go press shift and tab. Problem solved. We just talked about quite a lot there. Now, I think you understand if statements. If you don't, go back to earlier in this video, but I really quickly want to explain how last move works again. Sometimes we need to access a specific value in a list. In our case, we wanted to access the last move in our state. We use something called an index to do this. Like I mentioned, an index is a specific value in our list. Now, indexes start at 0. So 0 is your first thing, and 1 is your second. But Python has a little magic trick where you can use minus to go and access the indexes last in your list. In our example, -1 is the last move we made. Pretty cool, right? So we've given our computer big brain energy. Go over in your code. Remember, just press up in your console or type python3 space game.py, and you should see your code do this. If you go and use rock and then rock again, well, the second time, your code will definitely beat rock. Same with scissors, same with paper. Your computer will always try to beat the move that was used before it. So that's super cool. We've given our computer a much bigger brain. But despite the fact it's a lot more tactical now, it's also super predictable. We don't want the player to be able to guess what move the computer will play next. What if we made the computer only do this clever little trick sometimes? That kind of sounds complicated, right? We'd have to write a load of code that chooses a random move half the time, and it would have to use a move that would be beaten by the opponent the other half. And writing the code to that sounds really difficult. I don't know how to create a random number generator. Well, luckily, Python has a built-in function to help us. Remember how we talked about functions earlier? Well, Python has a ton built in that we can just go and use by importing them. And rather than writing all the code to go and use that function, we can just use it straight away. We don't need to write the code that makes it work. So let's get editing. Now, if you scroll to the top of your doc, you'll see on line 3, I've already imported random for you. Import random. Random is a Python library which lets us very easily generate random numbers. And, well, this is useful because, well, we need to randomly decide whether to do something or not. So let's scroll down and do that now. Hop back to your make move function and get ready to program. Now, I think we want to use an if statement here. We'll generate a random number that's either 0 or 1. That means 50% of the time it will be 0, and the other 50% of the time it will be 1. If it's 0, then we'll use the logic we just wrote to try and beat the player's last move. But if it's 1, then we'll do something else. Let's try writing that now. So, over here, just under where we set our last move, let's go and write an if statement. We'll say if, and I know how the random library works. We're going to say random.randint 0 or 1. So choose a random integer or a random whole number between 0 or 1 inclusive. So choose 0 or 1. And if this random number is equal, double equal remember, to 0, then we want to go and do something. Now, we only want the logic we just wrote to run if this random number that's either 0 or 1 is 0. So, well, it's Python. We need to make sure this if statement is indented because we only want it to run half the time. It's conditional, remember? So to do that, we've already written the code. We don't need to retype it all and indent it. Instead, we can just select all of this code that's already here in the if statement. Make sure you don't select return move, by the way, and then press tab. And everything you have already selected will indent by 1. Pretty cool, right? Now, we also want something else to run, which we'll get to in a second, if this isn't the case. So else or otherwise. So below this line, let's go unindent and unindent again, and we'll say else. So now, anything I write in this indented bit is going to run if the random number isn't 0. So in our case, if it's 1. Now, earlier I remembered that I could use random.randint to generate a random integer. But, well, I've forgotten how to go and choose a random item from a list in Python. This doesn't make me a bad developer. It's super common to forget little bits of programming knowledge. There's so many different things to remember. And so it is totally okay as a programmer to Google. See if you can Google how to choose a random item from a list using Python. Pause this video and unpause it when you've worked it out. Well, since you've unpaused the video, hopefully you found the answer to that. But if you didn't, don't worry. Here's what I would do. I would probably search for Python random item from list. One of the big skills you need to learn as a programmer, by the way, is learning what to Google. Then the top result there is a Stack Overflow link called How Do I Randomly Select an Item from a List? Well, Stack Overflow, by the way, is a really useful website which has tons of programming questions and answers, so we should go check that. It also seems to be vaguely about the right thing, so we'll give it a click. And the top answer says, hey, you should use random.choice. Well, that's pretty useful. See, every answer to most programming questions is just a quick Google away. Okay, let's go and use our newfound knowledge to write this code. So we're going to say, hey, if the random integer is not equal to 0, then we want to choose a random item from our list as a move. So we're going to say move is equal. Remember, we saw random.choice, and, well, I want to choose a random move. Well, where can I find my list of moves? If I scroll up, oh yeah, here it is. Valid moves is equal to rock, paper, or scissors. So I'm going to say a random choice out of the list valid moves. So this is just going to choose a random item in valid moves, rock, paper, or scissors. Awesome. It's important to periodically test your code to make sure stuff's still working. So hop back into your console, type python3 game.py and make sure things are working. If they are, hopefully you should see something a little bit like this. Your game is slightly less predictable than it was before, isn't it? And that means it's a much more advanced game. Great job, you just programmed something really, really cool. Our computer is now a lot more difficult to beat. Half the time the move it uses will be based on the player's previous move, and the other half it will be totally random. Wait, that sounds really familiar. Math time. Knowing that this event will happen 50% of the time is called conditional probability. Another example of conditional probability is a coin flip. 50% of the time it will land on heads, and 50% of the time it will land on tails. So conditional probability is the likelihood of an event occurring. Okay, let's use our biggest brain to run the biggest game. Let's make our computer even more tactical than it already is. Let's write some code so that it will keep track of all the player's previous moves, and 50% of the time it will use the move that will beat the player's move that they used most often. Pretty clever, right? Let's get coding. Now, I've written some code to help you do this. If you scroll up, you should see a function called most common. This function returns the most frequent move in our list, rock, paper, or scissors. We can go and use it on our state to work out what is the most commonly used move by the player. So let's try using it now. So if we scroll back down to our make move function, well, instead of saying if our last move was rock, let's change that to be if the most common move in our list of moves that the players used is stored in our, state. We talked about that earlier. So if our most common move is rock, then we'll use paper. Well, let's go and adapt this as well. If instead the most common move was paper, then we should use scissors. Oh wait, I made a typo. It's super easy to do that. Let's not have move common, let's have most common. Super easy to do that when programming. Don't be afraid if you do. And well, otherwise we'll just use rock. That logic still seems to work pretty well. Now, I showed you it earlier, but I do just want to point out a bit of our most common function, because we actually use a different type of loop to the one we saw earlier, a for loop. A for loop loops through our list of moves stored in state. Now, for loops iterate over a sequence. They run a piece of code a certain number of times. They let you do something a specific amount of times. So in our case, for each move in our list, it will run this code once. Now, after the for loop is run, we use conditionals to compare the count of each move. Whichever conditional returns true, aka whichever move the player uses the most, is the move the computer counters. Pretty cool, right? Let's go and test our code and see if it works for real. Well, hey, it looks like things are working pretty well. The computer is calculating the conditional probability of you making a move. And it's using this to decide which move it should use to beat you. Believe it or not, you just coded a really basic AI. Congratulations, you're officially a programmer. We just wrote a load of code together, and now it's time for you to put your newfound skills to a test. I want you to try writing your own rules into this game of rock, paper, scissors once this video finishes. Here's some ideas of what you could change. You could adjust how frequently the computer plays a random move. You could make the computer sometimes do the opponent's last move, and sometimes their most frequent to make it even more clever and unpredictable. Or you could be super evil, and sometimes play the same move as the player to try and trick them. So let's really quickly recap what we just talked about. You've just built your first AI. Seriously, super simple, but you built it. You learned the basics of how to make a game, you've learned that Python is a programming language, and you've also learned how to search for answers online. Being able to Google programming questions is one of the most important skills as a programmer. So keep using that. You really should use it. Okay, that's it for this video. Hopefully it was useful. As some next steps, you can go and try adding some catchphrases to the player too. You could try making your AI even better. If you want to do some research, as a spoiler alert, scientists have already found the best rock, paper, scissors strategy. And hey, you can even add a couple of extra moves too. Hopefully you learned something new. Don't forget to like and subscribe to this channel. And hey, I hope you have a great programming journey from here. See you later.